today we are reading the paper from UC Berkeley, just came out in October a few weeks ago, called the MemGPT. And the original title, so I put here as the main problem it tries to solve is the large context window for a large language model. So the actual problem they're solving, their paper title is toward LLMs as an operating system, and we will see why they call that way. A related paper, which is from Stanford University, was published a few months ago, called Lost in the Middle. And that is also trying to evaluate all the current large language model with known context and see how they perform, how the language model treats the retrieval. So if you use a retrieval RAG-based method, how do you utilize the content you retrieve, and is that effective or not? So they were doing evaluation on that. So today's paper was trying to address the problem from that they discovered from the previous paper. So let's look at the actual problem people face. First of all, we know that as a large language model continue to become larger and larger, certainly from GPT-3, 175 billion model, to GPT-4, more than 1 trillion model. And we were able to handle much longer context. So meaning what we call context window, the input length to that language model continue to grow. So because the more computing power we have, cheaper GPUs, and also certainly the larger model that requires us to really enable us to be able to handle so many tokens inside of the model. So the real question, what we see here, so the author listed all these models. Llama 1 is about 2,000 tokens. If you think back to BERT originally is only 512 tokens, is less than 1,000, and then gradually we grow that number. For Llama 2, we have about 4,000 tokens. GPT 3.5 is 4,000 tokens. GPT-4 now default is 8,000 tokens. Then you can, if you work with OpenAI using the API, you can access their 16K tokens, or even now you can access GPT-4 32K tokens, which is actually not bad. With 32,000 tokens, think about a Harry Potter book. Is about the first Harry Potter book is 76,000 words. So if you can handle 32,000 tokens, that's almost like half of the book. Ideally, what we really want is to really handle the complete book, right? So people can ask a question. If something happened, some story happened before, you can refer to that. So in the research field, in the development field, what people want is to be able to really handle more than 100,000 tokens. That is the ideal case, because that pretty much is one book. However, the author from this paper argues, we can do even better. Why not just one book? Why not many books, right? So the goal is to enable us to access context in an infinite way. So that's so they get their inspiration from operating system where you have limited memory, but then you have this virtual memory that's available for us to do some paging, what they call the method paging, to access the virtual memory. So that is what they propose. Essentially, another thing is they said just make the language model larger, having a larger context window is not a simple. It doesn't solve the problem we are facing. So the problem we're facing is even if you can have a model that can handle 100,000 tokens as input, the way we the attention model treats the input. So for example, if you say user asks a question, ask about say how to invest, and then you have a collection of financial advising document, and then you select the top 20 most relevant answers. When you and the right answer probably among those 20 relevant documents. When you present that to the as part of the context for ChatGPT to for GPT-4 to formulate the answer back, where this correct answer locates among these 20 documents actually makes difference. So if it's located on the first document, your answer accuracy is pretty high, but it dramatically decreases if you retrieve because when you retrieve, you rank relevance, the actual similarity score of the query and the retrieved documents. So when you rank that, if the rank for your actual answer is like the after 5, 6, then you get a very poor performance. And what's interesting that if the rank actually drop to the close to the bottom, it actually the accuracy goes back. So this is what that Stanford paper observed is you have this interesting phenomena of the beginning and the ending of the context was able to get attention, but the middle, so that's the paper called the lost in the middle. What's in the middle actually being ignored. That's the current limitation of the attention model. So this is when we studied the long context we gave it to the large language model, we could have a problem. Then the author basically argued that, first of all, we always limited by the number of tokens we can send to large language model. That's the input fixed input length. Secondly, is even we have a large context, they may not be used efficiently. So what is the intelligent way to allow us to bring up the real context in order to create a good answer, accurate answer to the user? So that is what the user is trying to answer the question. So the way they answer this question is basically through so-called context management. So if you think about there are two parts of the context what the language model actually has. One is what we call the context window. The context window is the number of tokens you send to the large language model. Among that, you can add the context, the retrieve the documents combined with user query. So you have a context plus user query plus some instruction. So this top part is the what we call in context, and we call main context. But we also have a lot of information we are not using when we send those contexts in. Those are we call external contexts. External contexts are histories of the previous conversation. It could be additional documents we haven't used, could be some database we haven't queried. So there are a lot of external contexts potentially can be accessed and we should be able to access. So the author basically proposed a way that when we interact with the large language model, instead of just send this static tokens, sequence of tokens into the language model, we should be able to kind of manage what kind of context we can give to the language model. So that's called a dynamic management of the context. Now, before we talk about how they do it, we first look at what they define as the main context. So the main context, as most of you have done ChatGPT instruction or any prompt engineering, you know that typically we give our instruction is composed of three components. Number one is called the system instruction. We say, give me explanation for this this area in the world, right? So this is instruction, and then there are some contexts. You said use the historical, say, documents from Wikipedia, or use this document I uploaded here. So that's a conversational context. You have instruction, and you have context. Then you have a working context. The working context could be the current things you want to discuss. Could be a location, could be a person, could be some query, some reference. So you have some the target context you want the system to handle. So that's the three part of the main context. So the author basically says the most important part is how we work with the working context to really get what the user is asking for. So the working context, say, just give me example for, say, a volcano, explain the volcano on a Pacific, right? So that's something I want to understand. The among that, you probably you give some volcano, some geographical explanation, some documents, but there are a lot of other documents out there, and so there are certain called external context. External context, they include two parts. One is called recall storage, which is something this user is interested and discussed it earlier or yesterday or last week. And then what we call archival storage, which could be a huge collection of all the geographical research or articles. That's called archival storage. Then we should be able to access all of them and bring that up to the working context dynamically. So that's what the author proposed. Now, if you look at the complete system, the way they how basically the question is, how do we go about doing this? How do we use the main context and bring out the external context dynamically and efficiently, right? So they built this system called the MemGPT. The MemGPT in the core is certainly there's a large language model, and for simplicity, the author is simply using GPT-4. They didn't implement their own or local LLM, but they actually now build the interface that allow people to use their local LLM combined with this whole MemGPT framework. And they also have an interface with AutoGen with other framework. So, but right now from the paper they're using GPT-4. So you can think about in the center is GPT-4. Then they are building this mechanism that triggers. So first you have an event. The event could be user ask a question. It could be user take some action. User upload the document. There's some system alert going on. So there's an event trigger. The event is then passed as a sequence of tokens as an action. So this is inspired by like LangChain, by basically action-oriented large language model. So you can reversely think about now instead of taking action, now we receive events. It's similar in the older days, like in the front end, in the web design, when the user move the mouse, the web page has to respond, right? And then you do something and then give something back. So the idea here is you can think about we are building a perpetual agent. This agent, MemGPT, essentially is an agent. It's a intelligent system that has a long-term memory that remembers many all the history, that has all the knowledge available to this agent. So that's MemGPT. And then it's waking up. It's waking up by certain event. The user starts to text. So when the user starts to text this MemGPT, it will access the current. It has so you will receive certain instructions. Will start to do in the conversation. But in the meantime, it also is able to access this external context. So in the process, the way they do this access is essentially also formulate as a action, a chain of actions. Essentially, the way we instruct. So this, because we are building an end-to-end language model. So think about the agent. The agent itself is a deep neural network that essentially takes the tokens, sends some tokens back. That's how we conceptually understand what is a large language model. Essentially, it's a deep neural network trained end to end using the data you have input data, you have output data, you train this model. So now the input data is no longer just words or instruction. The input data could be event, a trigger. Those triggers is part of the tokens that coming into the language model. Then the output is also not only just the words to talk, speak back. It's not only just a response. It's also including some actions, so action tokens. Once you see those tokens, you will execute those actions. So the action could be sent. So here there's a list of actions. It could be send some message on behalf of the user. Could be query a database or pause some interruptions. So all these are actions. So now we this is so the MemGPT is very interesting. So it's not only it deals with the memory management, the context management, but it also created this agent framework where it's handling the event input and also generate action output. So this I think it's very interesting, except I think the paper is very focused on engineering and implementation. The paper itself is not I wouldn't say as a theoretical paper, because they didn't actually prove like this methodology would converge, would work, but they do show some experimental results. So I think it's just a very practical, a useful tool they were trying to build. Now, whether that they do have they tested on certain data set, but yeah, we will see. So when we maybe end this talk, we can review, see how sound, how general this approach is, right? So that is this is just a system diagram. Let's go to the next slide. So there are two innovations introduced in this paper. In order to we will look at the detail probably in their code. The paper didn't give much detail descriptions, but essentially what it describes is there are two major methods it's used. So if we come back here, when we have a current context, but we know that our context is limited, we do want to access a much larger context. So the way that allows us to not be limited to the current retrieved documents or current conversational context is allow us to edit our context on the fly. So that's called the that's what they call self-directed editing and retrieval. So this part is very interesting. Is when the agent, when this MemGPT receive this like in context instruction with context with the query, it's supposed to immediately execute, send to the large language model to get a response. But it takes one step. It kind of paused for a few steps. It's doing some editing, some retrieval, continuously refining its own context. So that give it some chance to do some they call self introspection. So that when they review their own instruction, it has the capability of maybe go out to retrieve from the database some additional information, maybe change the context to something else. So this is the editing retrieval, self-directed editing retrieval process. This is the one they introduced. Then at the end, after they try to generate response, so basically this is first is the first part, the first arc. Then the second innovation is the second arc is after the large language model returns a certain result. What they do is they actually can continuously chain the events together. So if they say send a message, then they say, oh, what should I do next? Before sending the message, maybe I needed to write out the message and then edit the message, check the grammar of the message, so they can chain a sequence of events together. That's kind of self-reasoning they introduced. So that's the second innovation they did. But what's interesting is they put all this action framework together into this MemGPT context. So that's the second. So these are the two major innovations. I wouldn't say two major innovations. These are the two methods to support the context management. And other than that, they don't have theoretical discussions, but they do come up with some interesting data set. They created in order to demonstrate their method works better than the existing approach. They tested against some first multi-session chat is a data set that other people compiled before. Secondly is they created their own data set called the deep memory retrieval. It basically requires the large language model understand what's being talked like earlier. So they use the example like one person says the name, but they said that's not his name. He has a different name. Then the system actually has to verify and then update its memory. So those are the experiment that they have done. If we so the in terms of performance, they basically, if you look at MemGPT compared to GPT 3.5 and GPT-4, they showed that the accuracy in terms of answer is better than GPT-4, 3. So that's very encouraging. And also they use another measurement called the rouge. Let me actually explain rouge first. So rouge is a formula to it's a formula used by information retrieval in the older days, or do text summarization. So if you want a machine to generate a summary about a document, the human also wrote a summary and the machine wrote a summary. How good is the machine's summary? We don't know, right? So we actually ask compare. So we take the human summary as a ground truth, and so take the actually I so here is the reverse. So basically then we calculate the overlap between the ground truth and our generated summary. If our generated summary, so the recall is our generated summary against the ground truth. So actually sorry, I have to, the ground truth is a human summary. Okay, so this is the reverse. Sorry, the so here what we depending on how you define ground truth. So here the human summary in our case is the ground truth. So the recall is always the what you retrieved against the ground, how many real ground truths are out there. So that's the recall. Precision is how many you actually generated, and among them, what are the actual, the true words, right? The word that's in the ground truth. So the precision, and then the F1 score, essentially it's a geometric mean of precision and recall. So this is the formula: precision times recall divided by precision plus recall. Then there is another, let me put this back. So there's a root one. Basically, we look at every single word, 1 gram. If we see the overlap of how many single words are appearing out of in our generated summary against the total human summary, that's the root one, right? That's recall, root one recall. Then root two means if we take every 2 gram, 2 gram is every adjacent 2 words. And if you, so here, let me give you example. If we have a human summary says Apple acquired both, that's a human summary, a simple summary. And the machine, our generated summary, I think I needed to, so it's a little confusing using the term. So so this actually, sorry, I think I got it earlier. I was correct. I just and we can see why that's the case. Okay, so let me. So when we do root one, we look at the individual word that appeared in both documents. So that means Apple acquired both. The 3 words all appeared in both documents. For precision, we are measured against how many words we generated. So we generated 5 words, that's 60%. For recall, is we measure against the ground truth. Ground truth is 3 words, the human generated. So the recall is 100%, but precision 60%. From there, we calculated the F1 score. So that gives us 75%. And similarly, you can do root 2. Root 2 is the bigram. So here we have Apple acquired, that's a bigram, and then acquired both, that's another bigram. The only one bigram appears in the generated summary, the machine summary. So that is divided by the actual what's in the ground truth by the 2 bigrams. So the recall is 50%. Then in the human summary, there are 4 bigrams because Apple has finally acquired both. So we have 4 bigrams. Then 1 divided by 4, that's 25%. That's a precision. Then we use that to calculate the F1 score. Now in the paper, they have root L. L means the longest grams. meaning adjacent words. So suppose there are 3 words adjacent to each other appeared both in the machine summary and the human summary. Then we will have the root 3. So in this case, in our example here, the longest L equal to 2 because that's the at the most 2 gram that's appeared in both documents. But so sometimes you have L equal to 2, sometimes you could go up to 3 or 4, depending on how the machines generated the answer. So that is in our paper, in this paper. So if you go back to look at the RUGL comparison, what they did is they look at they take some ground truth. That's from the data set. The data set basically says this is how the human actually respond, right? Then the machine response. They generate a machine response, then calculated the precision and the recall for the longest overlapping grams. After the precision recall, then you can calculate the F1 score. So this is the score they calculated. And you can see that the MemGPT has a very good root score. So certainly people can argue that root score may not be that precise because maybe the machine use a very different language, different words. However, for our purpose, for most of the task, it's more information retrieval, like a user ask a specific factual question. So the root the real answer should be contained in the ground truth and also in our answer. In that sense, using root score, they said is still valid, still useful. And so that's one. Secondly, is the also use the precision to measure whether the ground truth has been retrieved. Okay, question, Uma? Yeah, you can unmute it. Yeah.
I was wondering what these terms mean, like persona 5 and summary 1 to 5.
So persona is this today's paper MemGPT. They generated several personas. So they have like a curious agent. Actually, I will show you later in their Discord channel. They show that they come up with they designed several personas. So there are 5 personas. So this is the top, the first half on the first 3 rows is persona 5, the 5th persona, right? And then the summary is average out of 1 to 5, 1 column to 5. And then at the bottom is basically the average result. Do you see what I mean?
Not exactly right now, but maybe I'll get a better understanding later in the talk.
They are building a chatbot, right? For every chatbot, they give the chatbot a persona. So the chatbot could be humorous, chatbot could be serious, the chatbot. So depending on what persona you give, the answer from the chatbot will be different. It's like you give a temperature to the ChatGPT, right?
Right, got it.
So, and then in addition to that temperature, you can add additional persona in the instruction set. And that allows the answer comes back differently.
And summary is summary of.
So I believe there are 2 tasks. One is document summary, another is a dialogue. We can look into the paper but essentially what this is a conversational task, right? So basically the top, I think it's a conversational. You still have a persona. The user chatting. They use a chatting persona agent to do some task. The task could be just chat with you continuously, or the task could be help you find information. And so for every persona, there are certain kind of result. coming back. And if you want more detail, we can go into the details. But the high level understanding, if you just look at the chart, the table, the bolded letters, numbers, essentially basically says this MemGPT did very well comparing to GPT-4 and the GPT-3. And then in terms of root score, certainly precision is not as high as the GPT-3.5, but their F1 score and the recall is pretty good. And most time we care about the F1 score because it's an average out of the precision and recall. So that is basically that's the experiment. It's not I would say not extensive experiment, not a 40. I mean, it's just some limited data set. So yeah, since you're asking that question, let me actually show you a demo. So the demo is very interesting. What I want to show is you can actually access their, excuse me. Sorry. Okay, so let me see if I can share my Discord. So for example, in the paper, they mentioned that they have a Discord channel. You can join. So let me open up my Discord channel, see if we can actually see that in action. Give me 1 second. Okay, good. So let me share my screen. We'll see this it's very new. This just came out in, I think October 12th. October 12th is, say, 3 weeks ago. Yeah, about exactly 3 weeks ago. So let's see, I can share my Discord channel with you. So now you can see this is a Discord channel. You can have a private conversation with a MemGPT bot. If you join their Discord channel, and they give you very detailed, this is the part that's very good, is for the authors. They really put in a lot of engineering effort to build this Discord bot, this bot that, and then they have this channel to support. So if you go there, you see their FAQ to help you actually set up your own private chatting with the bot. This is just all the settings, and there are support other things. What I want to show you is in my private conversation how the bot behaves, right? So let's take a look at the private message. Oh, where's the private? Okay, let me see. Where's private message? Yeah, here. Okay. So I want to show you. So in the beginning, I have to do. Let me go back all the way to the beginning. You can see how it's very engaging, very interesting bot. So if you can read, basically it does some self-inspection, and its self-introspection is very interesting. Okay, so it's very funny. It's like a real human being, right? And so this is a beginning of the chat. I ask some questions, so it's not serious in the beginning. Just give me some random answers. LLM is a quantum jumper, blah blah. So I said I'm not interested in fiction. Give me some real answers. And so you can see the bot said, make some very funny comments, but this is all to itself. So the bot say they want a real update, not fancy gibberish. So they really understand what the user is like aiming for, right? And then, so it try to give me some information, even though it's still hallucination. So it says Google's model. Oh, Google's model code name the hyper. This is a fake name, and also OpenAI's Pandora. I don't know if they have Pandora. I believe it's not there. So this is all kind of hallucination. So I keep asking to get some more serious information back. And then now it's actually hits its limits. It basically says my knowledge is only including information up until the year 2022. So it's somehow it's able to connect the dots. So in a way that I think this conversational bot has a lot of very interesting quality there. And then you can see in the background, so what they, the way the bot, they also did a very smart implementation is to reduce the cost, because this is a research group. The bot is not using their own computing resource. It's actually using my OpenAI API. So they ask every user to upload their own OpenAI API key to do this private conversation. So I have to give them my API key. Then they use that, they save that and build this. They have this architecture, the bot architecture, but each user is using their own computing resource to generate the answer. So that's I think it's a very smart way to engage a lot of users without costing them any money. That's this is very interesting. The yeah, so what another thing I was trying to test is how it in the paper they mentioned they can change. If I say my name is different, they will change the name, right? So so this here I'm asking the bot to say, do you know my name? And so I gave a name, then later I changed the name, if you see later. So I said, but I recently changed my name. And so the bot says, oh, name change, that's pretty major. So it does this funny self-talk. And then it now comes back. So it then now updated the core memory. You can see. And then later, if you can also print out this bot's main memory, so you can see later. Let me show you. So the main memory is in the beginning of the conversation. Each user enters their personal profile. So this is the old profile, and then it has a new content update. So the content update is I gave a name. Right, so this is just it's a simple example that shows how it manages the internal profile. There are let's see, in the end.
Junling, can you, if I may ask, so can you explain? So what's the difference between the text in italics and the text in normal format?
Italics user never see, actually. This is their internal chat for this bot.
But where is this coming from?
Its own internal chat. So this is the response.
But the italics, where is that coming from?
It comes from MemGPT design. So it could be they send a personality to GPT-4 to return back, but it's controlled by its design. And then after that, it send maybe a second round to GPT-4 and then generate the real answer back to the user.
The
So
italics
they do
text,
like two
is that
separate reasoning. Yeah.
the italics text, is that generated itself by an LLM?
Yeah, we can do a conversation now. You can see how it actually works. Let's type something here. So let's see what, let me make this expandable so that everyone can see how we type. Okay, so let's talk to this bot. I think it's supposed to be a perpetual forever conversational bot, right? You should remember everything we said earlier. So what do we want to ask? Give me a sentence. But okay, so let me just ask how to create a new picture with GPT-4. Okay, this is a very just a knowledge question. You see the you see it's doing the italic, right? And also I'm giddy with the thrill. It's so funny. So now you can see the answer comes back to the user. Is this? Did that answer your question? Uma?
I think the question is the same. Like, so I'm just trying to figure out like the difference between the italicized text and the normal text. So, like, so for example, if you go to the ChatGPT website, right? So you ask a similar question and it will give you an answer. But here it seems like MemGPT is give it like it has some like it's giving you two types of answers. So one is something that it is
it's not a two-type answer, it's a reasoning step. So the first answer they generate first, they use that as a reasoning. They use that to enhance the answer of the second answer.
But that reasoning, is the reasoning itself coming from GPT-4?
Yes, ultimately it's generated by GPT-4, but the reasoning comes from their internal procedure, a persona. That's where the persona is. If you look at here, the persona of this core is a starter persona, right? Persona defines how you generate that the first response, internal reflection, right? So here you can see your name is this whole persona definition. So they will send this whole thing to ChatGPT to generate that first answer. So basically say you identify as a neither male, you are curious, empathetic, extraordinary perceptive, designed with cutting edge technology, you explore emotions, self-awareness. So all these are instructions to LLM to create a persona. And this persona is persistent. This is what's unique about this. They have this persona for this chatbot. So this in the core, this is what they call core memory. This is the in the center, right? The rest is they use this to do reasoning, to answer better. So what they propose is having this persona plus some context, they can do better job. That's the whole point, right? So this is what they introduced.
So it is kind of self-prompt engineering, basically.
Yes. self-reasoning. They kind of chain of reason, chain of thoughts. So the people now understand that the chain of thoughts lead to better result. That's been proven by many other papers. So when you do self-reasoning, your answer will always be better. So what they did is they used this persona to prompt the first result, and they use the first result to generate the second result. Yeah. But what I really like is all this self introspection. I'm just amazed how they all this.
But another question is that, like, what if I don't want that? Like, so am I as a user? Okay, so as a user, I'm able to change this persona.
I think so. I select a default persona, right? So in here, in the FAQ, you can see how do I select between agents, right? So there are different kind that you can select. Yeah, that's why they said they have 5 personas you can choose from. Yeah.
Right. So for example, I mean, I don't know that much about, you know, chain of thought reasoning, but that's not really that's a pretty standard
reasoning
concept,
is,
right?
chain of thought reasoning is come from instruction. So can you ask if it thinks June is a machine or human? Okay, let's see. Okay. Let me actually let me go back to this conversation. So say, do you think I am a machine or a human? But I already told it explain your reason. This should be an easy because I already in the profile defined myself as a human.
I think the question had something else.
Oh,
it wasn't.
Oh, ask it yourself, not me, right? Ask it. So here it defines. So in the persona it says, you identify as neither male or female, but your voice can be soft and soothing. So, okay, we'll see. It's funny. Interesting. All right. So, that aside, fun aside, you can definitely join the Discord. They have a Discord link from their main website called MemGPT.ai. If you go there, you can find. I want to show you one more thing. Is their code base. I think it's worthwhile to take a look at their GitHub. So because it's the installation is actually quite simple and easy. Let me show you. Share with you. Okay, so this is the MemGPT GitHub from this first author's repo. You can see here they give a very good instruction. So now you can do AutoGen with MemGPT. You can do local LLM, and instead of a GPT-4, you can use your Llama 2. But they do said that the Llama 2 result is not as good as GPT-4. Certainly, in terms of capability. So basically, and then you can click on this link to try out that. So once you install a simple installation, you download the package. you can just call the main.py and then you can start a conversation. So this is very straightforward. What's interesting is they allow you to talk to your local file or SQL database. And that part is, I think, is the most valuable, right? You want to be able to allow this chatbot during conversation access your database. And they do have a code for you to actually do this inside this repo. So this is very useful where you actually can load. So the way when I start my first bot with, essentially I just type this profile, a key, an OpenAI key, and then create, then the bot is initialized. I think it's also very smart way. If you want to deploy a chatbot and for the user to test, and not costing you any money for spending money on OpenAI, you can just let the user to enter their own key. All this step, it's very, I think, very innovative. Then the installation, you can just do a MemGPT installation. That's all you need. What else? Yeah, so let's see. Oh yeah, this part is how you connect it to your database. So the way it's able to talk dynamically, like using during conversation, access the database and using the database information is you can load the database into the current conversation during the conversation. So as long as you give the basic database information, like where you access the username, essentially you can access the whole database for you. And you give some schema here. Then it basically can actually do a search in the database. So this is pretty cool. This is the part I want to share with you. All right. Any other questions? Any question? All right. Is it so?
I do.
Yeah. Go ahead.
Thanks, Junling. I have to say, overall, I liked their GitHub repo a lot. I even looked through some of the code, and they did a really nice, clean job with the code. Like you said, they had a lot of nice functionality. But when I read the paper in detail, it left me wanting more. I felt like it didn't really go into testbed experimental setup description in any detail. And that's very important to actually assess how good are the actual performance numbers. The performance tests seemed a little bit rudimentary. And what I'm also curious about, and I don't know if for any reason you would have any insight on this, but like, for example, how does MemGPT itself work? For example, with the document retrieval aspect, the fact that they have virtual memory, so that, I mean, of course their performance would be, maybe they read every single document. When do they stop reading documents? What's their internal algorithm of how they use the memory and when they stop? And that's important because, of course, their data could be great if they just read everything, but there's also a difference. There's a trade-off between latency and actual accuracy. And that's just like nowhere described at all. And so I couldn't tell by looking at the code. It didn't feel like this type of thing was tunable, although I didn't look in too much detail. But I was kind of curious your impression about like along these lines.
Right. What I understand is when they load this database connection, if you see in the code, they have a dynamic access to the whole database, and the database retrieval is very fast. It's instant, right? Because they assume they have a vector database. The vector database is essentially it's a constant time retrieval. So you actually don't worry about the retrieval time. Essentially, that says you can access, depending on the query, you can access all the documents. of course they have to be ranked, right?
That makes sense. Now, let me, and what you're saying makes perfect sense, but I guess what I wasn't clear on is, for example, they're going to go back and forth to the LLM many times to get a final better answer. And the thing is, they can keep going back until they exhausted the entire database. So of course their results could be better, but the latency could be horrible because how many times they're going back and forth to the LLM. They don't explain that at all. And that's where I get concerned about the latency and how trustable are the actual accuracy numbers, because it's a very fine balance here.
Okay, what is, given that my conversation with the Discord is pretty fast, right? My belief is that they don't do multiple round with LM. They refine their LM results before they actually send the final result to LM. That's a good question. How do they generate their first?
For conversation, it might be easier than document retrieval. When you're looking up knowledge in a large vector database, and you got to keep going back to the LLM, because then you got the context window limit. So
yes, so the paper did in the end talk about their limitation, and let's take a look at their search and retrieval limitation. So okay, let me actually share this part. Meeting summary is AI companion. Okay, enable. Okay, got it. Okay, all right. So let me share the PDF file. All right. So they talk about the limitation in terms of they use OpenAI GPT-4 model where they don't know the inner working have been fine-tuned. So this is not about the speed. Okay, so this is just they don't know what's inside the GPT-4. But is there limitation on their time? I don't see. So they do a search retrieval. So basically what they said that the retrieval is pretty fast. Non-context LM. This is related work. Okay, this is not their work. So let's see there how they do the work. Multiple data sources. So this is a concatenation of data source. Let's see how they do information retrieval. So here they have this database. They're paging one result. Yeah, so they do this back and forth. Benchmark against the fixed. So they're basically a benchmark against the fixed context. So they select a question and they evaluate the reader accuracy. Evaluation both they use a FICE index. So they already do all the embedding, all the document has embedding. So the embedding search is pretty fast. Let's see the entire set load into archival storage. So the entire document set is loaded into RAM, right? So retrieval is very fast, but do they do refinement? Good question. We need to see if they do refinement iteratively with the LM. I'm not sure. I don't think they do iterative refinement.
That would be the benefit they bring, right? Since they're not limited to the context length, they can send multiple messages to the LLM with different. Of course, any agent can do that. but they did it for us, so you don't
But
have to
what
write your
they
own.
say is that they're doing OS themselves. They're paging the memory in and out. So it's not to the LLM, it's to themselves. They figure out what memory to retrieve. Maybe they do reasoning themselves and then send something back. Fixed context
But
baseline
how?
performance kept roughly at the performance. Okay, yeah. It's making multiple calls to the retriever. It's not making multiple calls to the LLM. So retriever is locally hosted, right? Actively retrieves document from its archival. It's doing multiple retrieval. So several rounds of retrieval because it's doing reasoning on if I retrieve first set, do they satisfy? Am I happy with the result? Right. So they are doing reasoning on that.
But
Now
the
where does that
reasoning.
reasoning? Yes, go ahead.
Well, the question is that the reasoning, as far as I understand it now, because they are not adding any intelligence themselves, any kind of reasoning has to be done by the backing LLM, right?
That's
Beca-
true. They use
right. So
GPT-4.
right.
Yeah.
So any kind of reasoning, let's say, like I want some kind of summarization on or reasoning over a set of documents that I have. With an infinite context window, like I should be able to send all of them to GPT-4, and then I'll get some something back, right? So when they talk about reasoning, like, is that what they're doing?
I think so. Their fundamental language model is a GPT-4. I think Russ is correct. They do several round trip to a large language model. Yeah.
Yeah, so as he has pointed out, like that could be multiple queries, and that can add up to your cost. You have to provide your own, querying an LLM is a pretty expensive a proposition, and you're depending upon somebody else. And if you don't know, then like as a user, like, do we have any visibility into the number of queries that we'll have to send to the LLM, or is that just an arbitrary number that MemGPT will decide for us?
And let's see, they do multi-document retrieved. Maybe they stop at a certain. It's not clear. They didn't wrote. Let's see, Mem4.
Yeah, for example, AutoGen, which does
Yeah.
integrate with MemGPT, AutoGen has abilities because AutoGen has where it can have agents talking back and forth over and over again until they finally answer the question.
Right.
And what you can do there is like you can tell them only do so many round trips, to kind of limit your cost and the latency. I didn't see that in MemGPT's APIs, but
they didn't tell you
but
how
this is
many
hot off the
rounds
press.
they do.
Yeah, this is hot off the press. So I'm sure they'll be iterating on this. I think they just wanted to get this out quickly to get community feedback and support.
Yes, that's right. And that's exactly what they said in their GitHub. They said that we want to get user feedback. And that they just recently connected to AutoGen. So all these are new. This is very new. Probably they will keep refining, giving more control to the user. I believe probably they have a threshold, maybe like say 10 rounds, whatever, right? That in order for them to respond fast, they have to set a threshold there. Yeah. Okay, cool. Your preferred color depends on day of the week. What is that? Stephen. Interesting. Inconsistent information. Yeah, we could give inconsistent information to the bot and see how, but depends on how you formulate that question. Yeah, okay. So, yeah, very interesting. I think also I just took a look at AutoGen. I think it's very interesting. It uses a so-called multi-agent conversation. Essentially, each agent is doing some reasoning, right? And it's very easy to set up. Microsoft Research put their resource behind this. So I think AutoGen also is more advanced than Nanchain and AutoGPT. So yeah, and it just came out in August. It's so I think it's worth playing with. And combining AutoGen with this today's MemGPT could be interesting. And also it suggests building a Discord bot is pretty viable. Just like anyone can build a bot. Before, I always thought we should build a WhatsApp bot or build some bot, a text bot, right? You do the text messaging. If you do text messaging, it's expensive because it costs you to send a text message. WhatsApp bot may be easier, but it still has some hurdle because what I felt is that you have to register the business, and then there's this approval process. I think Discord maybe is the easiest one now. All right, any comments regarding today's paper? Okay, cool. If no comment, we can end today. We can end
I think
here.
Yeah. I think for me personally, like the best way for me at least to understand the concepts in this paper would be to go through an example that, you know, like here the user enters message A, and then what exactly is MemGPT doing that's different from sending the same message to, you know, ChatGPT or pick the LLM of your choice. I mean, one thing that, you know, one naive way that I can think of, you know, getting around the limitation of context windows is that, you know, at specific intervals, you just ask the LLM to summarize your chat, right? And so that becomes harder and harder as your as the number of messages in your chat go up, because, you know, it has to like keep summarizing. So maybe they're doing something similar, but I'm not 100% clear on what exactly are they doing.
Yeah,
that
it sounds like for me, the idea is they call iterative summary. There is a paper on iterative summary. And iterative summary is a way to allow you to recursively like refer to previous chat. That's why they said they can build a perpetual chatbot, right? You can have infinite memory because when you go back to one day, that one day refer to something happened before, depending on how far you want to go back.
Right.
So that could be a solution to limit your total content.
Right.
Yeah.
But it's pretty neat because while they have the summaries, they also have the full exact message content of the entire history, I believe, in the archival as well. So, for example, if you're asking a question about a specific fact, they could, you can imagine they could do a summary, they could do a semantic lookup where they could find all the previous chats that had to do with this topic, semantically similar, was it cosine similarity or whatever?
Yeah.
Then summarize just those instead of summarizing everything. So you can kind of try to minimize your loss. The fact that minimize your loss. So the fact that they have the full message history in addition to summarization allows some optimizations.
Right.
Yeah.
Right.
Yeah. I think it's pretty neat. And definitely it's worth taking a look at their GitHub code. That would give you a complete context of how they implement that. I think so in their GitHub, they have, let me actually quick share with you. We have a little bit of time. Let me see, where's the GitHub code? Actually took a look earlier today. Okay, here we go. Just, so if you come to their inside here, this is their main folder, MemGPT/MemGPT, and in the and all of this give you a much better idea of how they do. But in this main.py, you see how they actually did. This is interface, most interface part. But you see how they interact with the external system. Yeah. Take some time to read those code, but I just want to bring that up.
The external system is just basically semantic lookup, right?
Yeah.
That's
particularly the emphasis is a vector database, meaning everything's embedding. So the search is embedding based, so that can be fast. Otherwise, it will be very slow. Otherwise, the search result won't be good. So very specialized for document retrieval. It's not generic like SQL. Maybe SQL can be fast too because the SQL database is already optimized. But they specifically mentioned that for documents should be embedded, already get their embedding. Basically, you have to pre-process all the documents, convert them into a vector to save in the vector database. That part has to be done first. And then in the real time, you just instantly access those documents.
So this sounds really similar to, what people abbreviate as, RAG, retrieval augmented generation. So
yes, the problem with RAG is, as they mentioned, it's fixed context window. You retrieve only the first 20 documents, right? That's RAG.
Right.
But for them, they said, in addition to these 20, I can access all the rest when I do reasoning.
But how do they do that? So for example, like for RAG, I think what you have to do is that you have to specify the number of similar documents to your query. So that's a limiting factor. So do they just like increase that number? So instead of let's say
no, they cannot. Their total context window is the same, so they cannot increase the number of documents. But what they do is they add the reasoning on top of so they actually decrease the number of documents they select, right? They have to leave some tokens for reasoning. So basically, they're doing back and forth with the LLM to say, are these enough? Do I get enough information here? If not, should I ask more questions? Then they ask more questions, get additional documents. Then
I see.
Yeah.
That makes sense.
Yeah.
So basically, it's an iterative RAG.
You can think about that. They call editing and retrieval, in context editing and retrieval.
Oh, I see. Interesting.
Yeah, and what I'm more interested in the last part is the function training. Yeah, they can continuously execute on additional functions action. So yeah, and I think it's an agent framework, which is cool, very cool. Essentially the same idea as AutoGen, but from different angle, right? AutoGen uses multi-agent conversation to do action. Then, but they have this centered in context, so-called OS system, and then take a certain kind of triggered by action, execute a certain action. So it's like one agent. It's very clearly defined one agent system. Yeah. So yeah, I think this is exciting. Even though I'm not clear the last part, the action chaining, how they actually do all the magic stuff, right? They didn't show much.
They gave a tiny little hint. They mentioned part of the system context they send to OpenAI includes the function schema.
Oh, they use OpenAI function call. Yeah.
It's what it seems like they do it. And I think that's why they only support certain local LLMs, because a lot of local LLMs don't support that function calling mechanism of the Open API, of the OpenAI API. So it seemed like that's what they were doing.
I see.
To me.
Yeah, of course, they can only innovate on certain part. They cannot do everything, right? I think because they're just students. Most are students at this time. Okay, great. I think that's yeah, we got a very good discussion today. So, if no more questions, we can end here. And I will pick another paper to read in 2 weeks. If you have any suggestion, yeah, send me suggestions. We can read those papers.
Thanks, Junling.
Okay, thank you. All right, thank you. Bye-bye. Good night. Bye.
Thank you.